Good evening, everyone. So in the previous sessions, we discussed about what is Kubernetes, Kubernetes architecture, how to work with Kubernetes, right? How to deploy the pods, how to use the services, how to use deployment strategies, ingress, Helm, all these things we discussed. So Kubernetes is an orchestration engine. It will manage containers of our application. Kubernetes is also called as K8s and it is an open source platform. It will manage containerized based applications. Kubernetes developed by Google company using Go language. Later it donated to CNCF. Okay. The first version of the Kubernetes released in the 2015. Kubernetes is replacement for the Docker Swarm. So we have seen some differences between Docker Swarm and Kubernetes also. Docker Swarm auto scaling capability is not available, whereas in the Kubernetes auto scaling capability is available. Good. We have seen architecture of our Kubernetes. So here Kubernetes will follow master and slave architecture. It will follow master and slave architecture. Master is also called as a control plane, which will contain API server, scheduler, controller manager, etcd. API server will receive our request, will store the data in the etcd. Then scheduler is going to take the data from etcd and it will schedule the pod's execution. Controller manager is going to take care of that process. Kubelet is a node agent. Kubeproxy will provide the network details for that. Docker is a runtime. Pod is the smallest building block that we can execute on the Kubernetes cluster. So one cluster can manage multiple worker nodes also. In order to work with this Kubernetes architecture, in order to execute the Kubernetes containers in the Kubernetes, we are using kubectl. Kubectl is a CLI, right? Next, we have done setup of the Kubernetes cluster. Kubernetes cluster we can do in two ways. One is by using self-managed cluster and the second one is provider managed cluster. Self-managed cluster again we can do it in two ways. One is by using Minikube with a single node cluster, or we can go for Kubedium, which is multi-node cluster. Managed cluster means cloud provider will provide the cluster. You just need to use the cluster which is created by them. AWS EKS we have seen, and we have seen Kubedium also. Using Kubedium, we created our own cluster with multiple nodes. Multi-node cluster with the high availability we configured. And in the AWS, we have created EKS cluster, right? Fine. So managed cluster, we created self-managed cluster with one master node and two worker nodes. Using Kubedium and kubectl, we are able to deploy our applications. So these are the core components that we discussed in our Kubernetes. Container. Container is a runtime process of our Docker image. Containers we can't run directly on the Kubernetes. Containers we are going to execute as pods. Pod nothing but a smallest building block that we can execute on the Kubernetes cluster. Namespace nothing but a cluster inside the cluster. It is something like a package. So all your applications a package can be executed as one package using a namespace. You can create the namespaces and you can delete the namespaces. When you delete a namespace, all the components, all the objects associated to that namespace also gets deleted. Next, when the pod is created, by default, that pod we can access only within the cluster. If you want to expose the pod outside the cluster also, then there is a service concept. Service concept is divided into three types. One is a cluster IP, second one is node port, third one is load balancer. Cluster IP means for the pod, one virtual IP will be assigned. Using that IP, you can access that within the cluster. If you want to expose the pod outside the cluster, then you need to create a service for the pod. Pod manifest should be attached to a service by using node port. When you give the service name as a node port, Kubernetes will assign a random port for that. And using node IP, worker node IP, you can access that pod outside the cluster also. When you are using any cloud to set up the Kubernetes cluster like EKS or AKE, then you can use the service type as a load balancer. In the cloud platform, load balancer will be created with a DNS. Using the DNS also, you can access your pod. Next one, volumes. So by default, whenever you run a container, containers will be stateless. Once that container got stopped, the data we are going to lose. To make our containers, to make our pod as stateful pods, we can go with volumes concept in the Kubernetes. In the Docker, we have seen already volumes. In the Kubernetes also, we have volumes concept. Next one, replication controller. So here, when you create a pod manually, then if the pod got deleted, if the pod got crashed, it cannot reschedule. So creating the pods manually is not recommended in the Kubernetes cluster. For that, we are going to use replication controller, replication set, daemon set, stateful set, deployment concepts. Replication controller we can use to create the pods with replicas. When you give the replica as a one, always it will maintain one replica of the pod. So if the pod got crashed, it will reschedule another pod. Self-healing capability we will get with the replication controller. We have a replication set also. The difference between the replication controller and replication set is labels and selectors. You can write multiple selectors, multiple labels by using replication set. Right. Daemon set. Daemon set means if you want to execute a copy of the pod in all the worker nodes, then you can go for daemon set. If you want to execute the copy of the pod in all the worker nodes, like a log collectors, then you can go for daemon set concept. Stateful set that we haven't discussed yet, guys, we will discuss about it. Deployment concept is there. Deployment is the most recommended approach to deploy the applications on the Kubernetes cluster. So there are deployment strategies also available. Recreate, rolling update, blue-green concept we have discussed. And HPA is also available, metric servers. We installed metric server on the cluster and we are able to scale the pods horizontally. Auto scaling also we are able to do. Next one, ingress concept we discussed in the Kubernetes. So ingress is used to divert the external traffic to cluster services. For that we used ingress. Kubernetes core concepts. Next, Amazon EKS. We created EKS cluster by using AWS. The advantage is when you go for EKS cluster, you need to manage only worker nodes, master node. I mean, control plane will be managed by AWS only. You just create one machine with and install kubectl and connect to that cluster. Connect to that cluster. That's it. So if you go for provider managed cluster, you just need to create your worker nodes and connect those worker nodes to control plane. So you will not have any control. You don't have any control on this control node, control plane when you go for EKS cluster. We have already created EKS cluster in the AWS, right? Multi-node EKS cluster we have created. Then in the last session, we discussed about what is Helm. Helm is a package manager for Kubernetes applications. So in the Linux, we are going to install some softwares. In the Linux, we are installing some softwares by using yum package manager, by using yapt package manager. Similarly, if you want to install any application on the Kubernetes, then you can go for Helm. Helm is a package manager for Kubernetes applications. Helm allows you to install or deploy applications on the Kubernetes cluster in a similar manner to yum or apt for Linux distributions. Okay, Helm manages resources, packages through chats. One application will be called as one chat in the Helm. What is the meaning of a chat? Chat is just a collection of files organized in a specific directory structure. What is a chat, guys? Chat is a collection of files organized in a specific directory structure. Organized in a specific directory structure. The configuration information related to a chat is managed in the configuration. Finally, the running instance of a chat with a specific config is called as one release. Chats will be created. Suppose I want to install metrics server. For that, we can go for Helm chart. Helm chart we can use to install metrics server. I want to install Prometheus. I want to install Grafana. I want to install ELK stack on the cluster to monitor my applications running on the cluster. So to monitor our applications running on the cluster, we can use Helm and we can install those applications. Helm is a package manager. So what is this Helm architecture? So we are using Helm client. We installed Helm software in our machine. So we are using a remote machine to connect with our Kubernetes cluster, right? So in that machine, you can install Helm. Helm is having a repository for the charts. Helm charts are maintained in one repository. So which application you want to install on the Kubernetes cluster? For that application, you need to configure Helm repository. For example, I want to install metric server. Metric server repository I will add to Helm client and I will execute that install command. Then the Helm is going to communicate with the Kubernetes cluster and it will send the request to Kubernetes API server. We know the process, how the API server is going to store our request in the etcd, then what scheduler is going to do, all that stuff we already discussed. Helm is a package manager. We are installing the Helm software in our machine and we are going to add the Helm repository and we are going to execute the install command. Then it is going to install respective software in our application. Okay, guys. So we discussed about Helm and how to install the Helm, how to install the application by using Helm package manager. Next. So today we are going to understand what is Prometheus and what is Grafana. Prometheus is an open source systems monitoring and alerting toolkit. Open source software. It is used to monitor our systems and it is going to generate alerts when something is going wrong in our cluster. We are going to run our applications on the Kubernetes cluster, right? So multiple services will be running on the Kubernetes cluster. So I want someone to monitor my cluster. I want to generate alerts when something is going wrong in my cluster. For that, we are going to use Prometheus application. Prometheus collects and stores its metrics as time series of data. So when the Kubernetes cluster we are using to execute our application, continuously requests will be coming to our applications which are running on the cluster. So when the applications are executing, some data will be generated. That data we can collect and we can execute some metrics on the data by using Prometheus. Prometheus is purely monitoring tool for our Kubernetes clusters. Okay, it provides out of the box monitoring capabilities for the Kubernetes container orchestration platform. So we are running our applications as containers in the Kubernetes platform. Actually, we are creating the containers by using Docker. Docker containers we are running on the Kubernetes cluster. Docker is containerization platform. Kubernetes is orchestration platform. Okay, so by using Docker, we are packaging our application as a image. That image we are executing as a container. That container we are executing on the cluster. That cluster is Kubernetes cluster. Kubernetes is going to manage. Kubernetes is going to manage our cluster applications on as a pods. So when our application running on the cluster, I want to monitor the resources. I want to monitor my systems and I want to generate some alerts from the cluster. For that, we are going to use Prometheus. Prometheus is a monitoring tool. Then what is Grafana? Prometheus is a monitoring tool. Then what is this Grafana? Grafana is a database analysis and monitoring tool. So we can analyze our data. Prometheus is going to collect the data. Grafana is going to analyze the data. Grafana is a multi-platform open source analysis and interactive visualization web application. So here you are going to install Grafana on the Kubernetes cluster. That Grafana will provide you one web application where you can see the metrics of your application in the graphs format. So data visualization will be provided by Grafana. We are going to use the combination of Prometheus and Grafana. Prometheus is a monitoring tool. It is going to collect the data, and that data will be given to Grafana. Data will be collected by Prometheus. Prometheus will give the data to Grafana. Okay, that Grafana is going to analyze the data which is coming from the Prometheus. It is going to generate a graph for you to analyze that data. Guys, Prometheus purpose is different, Grafana purpose is different. Both are used in the Kubernetes cluster for monitoring. Prometheus is going to collect the data. Grafana is going to show the data in the beautiful graphs format. Grafana is a database analysis and monitoring tool. Grafana is a multi-platform open source analytics and interactive visualization web application. It provides the charts, it provides the graphs, and it provides the alerts for the web when connected to supported data sources. So we are going to have a cluster. In the cluster, we are going to install the Prometheus. That Prometheus we are going to connect to the Grafana. Grafana will take the data from the Prometheus. It will generate a report for you. It will generate a report for you. Grafana will allow you to query, visualize, and alert and understand the metrics no matter where the data is available. Kubernetes cluster is running. In the cluster, our services are running. In that cluster, I will install Prometheus as a monitoring tool. Prometheus will collect the data. Prometheus will give the data to Grafana. Prometheus will give the data source. Applications data source will be given to Grafana. Grafana is going to understand the data, and Grafana is going to provide you a user interface with beautiful graphs, charts, and everything. Beautiful graphs and charts and everything. Are you clear? Are you guys clear? So this is the architecture of our Prometheus and Grafana. Okay, Prometheus server we are going to install on the cluster. The Prometheus server will be connected to Kubernetes, and it is going to get the data from the Kubernetes cluster, and Prometheus will give the alerts to alert manager. So using that alert manager, we can send the notifications through emails or whatever you want. Alert manager will be available in the Prometheus, and Prometheus can be connected to Grafana. Grafana is a visualization software. Prometheus is a monitoring software. Prometheus will collect the data from the cluster, and that data it will give to Grafana. Grafana is going to present the data in the beautiful graphs format. Okay, guys. Now, so let us see how can we set up this Prometheus Grafana using Helm charts in our EKS cluster. So in my AWS cloud account, my EKS cluster is running. Okay, so let us see kubectl get nodes. There are two nodes are running. There are two nodes are running in my EKS cluster. Can we see Helm is available? Helm list. Yeah, Helm is available, but there is nothing available. Helm version. Helm version is available. Helm version. -v. Helm -v. Unknown flag version. Helm help. Yes, Helm is installed in my EKS cluster. Now, using this Helm, we can install Grafana as well as Prometheus. Guys, you got the concept? What is the difference between Prometheus and Grafana? What is the difference between Prometheus and Grafana? Guys, can you tell me what is the difference between Prometheus and Grafana? Why we are going to use Prometheus and Grafana? Can anyone respond in the chat? What is the difference between Prometheus and Grafana? Why we need to use both? Why we need to use both? Prometheus is used to monitor and collect the data. What is the Grafana? Grafana is going to present the data. Prometheus is just a monitoring tool and it is going to collect the data. Grafana is used to present the data, visualize the data. It is going to give the data in the form of graphs, charts, and all. Got it? Now, in our Kubernetes cluster, we have Helm installed. Okay. So now, once the Helm is installed in our cluster, we can see Helm list. Currently, nothing is available here in the Helm. Now, I want to install Grafana and Prometheus. I prepared a notes also, guys, along with PPT. I will share these notes with you guys. Prometheus is an open source monitoring toolkit. Grafana is a visualization toolkit. Both we are going to install on the Kubernetes cluster using this Helm, right? The most efficient way used to deploy Grafana and Prometheus by using Helm charts. First, in order to install Grafana and Prometheus using Helm, we need to add that repository, Helm repository. Let me take the Helm repository, add the stable Helm repository, stable repository available. Then add the Prometheus repository to the Helm. As we discussed in the Helm architecture, first chat repository we need to add to the Helm, then we can ask the Helm to install it. Okay, so here I'm going to add Prometheus repository to the Helm by using Helm repo add. I'm going to add it. Helm repo I'm adding. That is already available. Then you can do Helm repo update. Once the new repository is added, you can just update that repository. Helm repository is updated. Once it is done, if you want to check it really the Prometheus community repository added to the Helm or not, you can just execute Helm search repo Prometheus community. Prometheus community repository is added to our Helm repo. You just check it. Is it really added or not? Yes, it is added. Prometheus details are displaying. That means Prometheus charts are added to Helm repository. Once it is done, guys, now we need to install the Prometheus as a Helm chart. When you use Kube Prometheus stack, it is going to install both Grafana and Prometheus at a time. You no need to install Prometheus Grafana separately. So there is a stack which is Kube Prometheus stack is available. So when you install this Kube Prometheus stack, it is going to install both Prometheus and Grafana. Okay, in single shot, both softwares will be installed. Both applications will be installed on the Kubernetes cluster. Let's wait. It is taking time. I'm trying to install Prometheus stack on the Kubernetes using Helm charts. It will install both Prometheus and Grafana. Yeah, good. Status deployed. So Prometheus Grafana status deployed. Now Helm list. Can you see the stable repository is added? The chart is added. What is the chart it added, guys? Kube Prometheus stack. That is what we added. We added Kube Prometheus stack. We installed that. Install stable Prometheus community Kube Prometheus stack. Now you check the pods. This Grafana Prometheus also going to run as pods on our cluster. So when I execute kubectl get pods, are you able to see the pods of Prometheus alert manager, stable Grafana, stable Kube Prometheus node exporter, stable Kube state metrics? Can we see this Grafana and Prometheus running as pods on the cluster? Who is executing? Who executed this Prometheus and Grafana on our cluster? Did I install these applications manually? I used Helm to install these applications on the cluster. I used Helm to install these applications on the cluster. What is Helm, guys? What is Helm? It is a package manager. I installed my applications on the cluster by using package manager. Okay, guys, fine. You can install Prometheus and Grafana manually also without Helm. There are some manifest files available. There are some manifest files available for Prometheus and Grafana. You can install them manually also. But what is the recommended approach to install the applications on the cluster? Installing them manually is recommended. Installing using Helm is recommended. Installing them using Helm is recommended. If you don't want to use a Helm, you can download Prometheus manifest file. YML file will be available. Using that YML, you can install. Similarly, Grafana manifest file you can download. How? We installed our Java web application, Maven web application on the cluster using manifest files. Similarly, you can take the YML files of the Prometheus and Grafana. You can install them manually. But the most recommended efficient approach to install these applications is using Helm charts, because you just need to add the repository and tell to Helm to install. Helm is going to install those softwares for you. Now, Prometheus and Grafana both installed using Prometheus stack repository. Once it is done, let's check it. What are the services running in my cluster now? What are the services running in my cluster? What are the services running in my cluster? Can you see? Grafana service is running in the cluster. Guys, can you see Grafana service running in the cluster? Can you see Prometheus running in the cluster? What is the service type for Grafana and Prometheus now? What is the service type for Grafana and Prometheus now? Service type. They also executed as a application, right? They also executed as a cluster. They also executed as a pods. They also executed as a pods. Grafana is one service. How we have a Java web application service, Maven web application service. Similarly, Prometheus is one service. Grafana is one service. What is the type of those Prometheus? What is the type of Prometheus and Grafana service? Cluster IP. Cluster IP. Can we access these services outside now? Can we access these services outside now? No, because they are having cluster IP. That means they are accessible within the cluster. They are accessible within the cluster. Okay, but now I want to monitor the cluster outside. Then what should I do? How can I access this Prometheus and Grafana outside the cluster? You can go for node port. You can go for node port, or you can go for load balancer. You can go for a node port, or you can go for a load balancer. So Grafana is one service. This Grafana is executing some pods on the cluster. Prometheus is one service which is executing on the cluster. It is having some pods. Okay, can you see what is the port number of the Prometheus? What is the port number of the Prometheus? Default port number of the Prometheus? 9090. What is the port number of the Grafana? What is the port number of the Grafana? Got it? 80. Now, currently they are running as a cluster IP, so they are accessible within the cluster. Now I want to access them outside the cluster. In order to access them outside the cluster, we need to change the service type. By default, Prometheus and Grafana service is available within the cluster using cluster IP. To access them outside, let's change it. Let's change it to Let's change it either node port or load balancer. I will make it as a load balancer. Let's go to our EC2 dashboard. Let's check the load balancers. In my AWS account currently, do I have any load balancer? In my AWS account, do I have any load balancer currently? No, I don't have any load balancer. Where is my cluster running? Where is my cluster running? EKS. My cluster is running on EKS. Now I will change the service type of Prometheus to load balancer, Grafana service type to load balancer. How to change these services? How to change these services? So there is a command. There is a command to edit these services. There is a command to edit these services. Got my point, guys? Let me edit these services. First, let me edit stable Prometheus service, kubectl edit service name. Syntax: kubectl edit service name. Edit the service. Go down. You can see service type as a cluster IP at the bottom. Here, I'm changing from the cluster IP to load balancer. I'm changing from cluster IP to load balancer. Save it. I changed it. Now go to Grafana, edit the Grafana service using kubectl edit service name. Go down. There you can see type as a cluster IP. Edit it. Make it as load balancer. Make it as load balancer. Done. Now I have changed both the Prometheus service and Grafana service. Now let us check SVC details. kubectl get SVC. Now can you see the service details got changed for Prometheus and Grafana? Grafana service changed to load balancer. Prometheus service also changed to load balancer. When the service type is changed to load balancer, can you check it? Two load balancers got created. Can you check it? Two load balancers got created. Why the load balancer got created? My cluster running on the EKS platform. It is managed cluster by AWS. When I execute a service with the type as a load balancer, then the load balancer will be created in the AWS cloud. Now using load balancer DNS, I can access these applications which are running on the cluster. Okay, so these applications are running. These applications like Prometheus, Grafana running on Kubernetes cluster as a load balancer type. Okay, Grafana is there. This is the DNS of the Grafana load balancer running with 80 port. This is Prometheus load balancer running on load balancer with DNS. Prometheus default port is 9090. Grafana default port is 80. First, let me access Prometheus DNS. Let's copy this DNS external IP. Go to our browser. Port number is what? 9090. DNS colon 9090. Are we able to access Prometheus now? Guys, are we able to access Prometheus now? Query, enable autocomplete, highlighting, enable enter, add a panel. You can add the panel, you can enter the time, execute it. Whatever expressions you want to write, you can add them to the panel. Whatever the notifications we are going to get, we can see them on the Prometheus. Okay, you can change the theme also. For the Prometheus dark theme, you can keep white color. Day mode, night mode themes also you can set on the Prometheus. You can customize the Prometheus alerts. You can see alerts, alert manager is available. Okay, when some alert occurred, when some alert happened in our cluster, those things we can see here. Those things you can see here. Graph, you can check the graph, you can check the status, targets, service discovery, service monitoring, show more details about the particular service. This is going to collect all the data. You can see all the alerts. Inactive 128, pending 2, firing 1, one alert is in the firing state. So like this, you can monitor the cluster by using this. You can monitor the cluster by using this Prometheus. Okay, guys. Now Prometheus is going to collect the data from the cluster and it is going to display you that data. It is going to collect the data from the cluster. Now, whatever the data that we have collected using Prometheus, I want to visualize that data on the Grafana. I want to visualize the data on the Grafana. So Grafana is also executing as a service with load balancer type. It is having a DNS. Copy the DNS of Grafana. Prometheus running on the port number 9090. Grafana is running on the port number 80. So directly you can access the DNS of Grafana. Grafana is a web application. Can you see that? We are able to access Grafana web application. So what I told here when I'm talking about Grafana, Grafana is a analysis tool. It is a web platform. It will provide a user interface. So Grafana I installed on the cluster using Helm. Okay, the default service type is a cluster IP. We can access within the cluster. So if you want to access this Prometheus and Grafana outside the cluster, you need to change the service type to node port or load balancer. My cluster is EKS, so I'm changed it to load balancer. One DNS got generated. Using the DNS, I'm able to access this Grafana. Okay, so what is the username and password for the Grafana? Default credentials you can take here. Default credential is username is admin, password is prom operator, Prometheus operator. Click on login. Okay, I'm able to log in into Grafana. I'm able to log in into my Grafana. So here dashboards are available. You can go to this dashboard, browse. So what type of dashboard you want to see? Do you want to see the dashboard of your alert manager? You want to see the dashboard of your etcd? You want to see the dashboard of API server? What kind of requests are coming? Control manager, kubelet, networking, pods. If you select the pods, now see it is displaying the graph. It is displaying the graph. Which pod details you want to get? Core DNS AWS node pod details. Okay, current rate of bytes received, right? You can view this. You can view this particular pod details. All the pods details you can watch. So if you want to change the dashboard, if you go to etcd, it is going to display that etcd currently whatever the data is available in the etcd. Currently there is nothing available in the etcd from last 15 minutes, last 30 minutes, last 30 minutes. Like this, you can check it. Browse, discard this. Browse Kubernetes API server. I want to get the details of the API server. Like this, you can visualize. You can see the data. You can see the data. What is your CPU utilization? A beautiful UI. The graphs are displaying for you with this Grafana. Got it. Alerts, notifications. We can explore more on this Grafana. We can create the dashboards. We can do the playlist. We can do the snapshot, library panels, browse, alert manager, core DNS, Grafana overview. So the Grafana is going to display the graphs for you. Grafana is going to display the graphs for you. Browse what type of dashboard you want. You can choose from here. Prometheus dashboard. You can see instances. See here, these are the jobs which are running on your cluster. In which machine it is running, it is displaying. See here, Prometheus running on this IP, on this instance with port number 9090. Right, kubeproxy, kubelet, API server, all these things are running. Okay, targets, defaults, target in the sync, average scrape interval intervention, scrape failure, samples, head chunks, head sheets, query rate, stage duration. So beautiful graphs are getting displayed for us. You can save this dashboard also diary. You can monitor these dashboards. So in the real time, our applications will be running on the cluster, right? So those clusters we can monitor by using this Prometheus and Grafana. These are monitoring tools. These are monitoring tools. Add your first data source, right? I'm giving the data source as Prometheus. Prometheus I'm giving as a data source. Okay, you can give the URLs of the dashboard and all. You can save it and you can test it also. Prometheus we are going to connect with the Grafana and we are going to check it. Now we are going to have Elasticsearch also for log monitoring. We'll talk about it. That log Elasticsearch also you can connect with your Grafana and you can monitor. Zipkin also you can use. Zipkin also you can connect with the Grafana and you can monitor that distributed logs of the application which are generated in the Zipkin. Those Zipkin logs also can be monitored by using this Grafana. Grafana is a visualization software. Grafana is a visualization software. Clear for all of you? How to install Prometheus and Grafana? How to install Prometheus and Grafana? Using Helm. Using Helm, how to install Prometheus and Grafana? Are you clear? Which dashboard you want to see? You can select it and you can see that dashboard. It will give you the metrics of it. What is happening in the cluster? What is the what are the instances are running? What is the CPU utilization of those instances? All the metrics can be monitored by using this Grafana. I have seen networking. You can see this networking dashboard. Receive bandwidth, transmit bandwidth, the packlets, errors, all these details you can monitor from this Grafana. Grafana is a visualization software. Sign out. You can log in into Grafana and you can monitor your cluster. Okay, so this is just for cluster monitoring. How many worker nodes are running? How many pods are running? How many instances are running? How many requests are coming? How the cluster is behaving? All those details can be monitored by using this Prometheus and Grafana. Prometheus is a monitoring tool. Grafana is a visualization tool. Are you guys clear with my point? Are you guys clear with my point? Prometheus and Grafana. Prometheus Prometheus is a monitoring tool. Grafana is a visualization tool. Grafana is a visualization tool. Okay, that is fine. Next one, we will be having one more monitoring tool for our applications in the real time, that is ELK. ELK stack will be available. Some people will use ELK, some people will be using EFK. Grafana will display the dashboard like this. Next one, what is ELK stack? The ELK stack is a collection of 3 open source products. One is Elasticsearch, second one is Logstash, and third one is Kibana. ELK stack will be used. Guys, Prometheus and Grafana is used to monitor cluster nodes. Prometheus is a monitoring tool. Grafana is a visualization tool. When we have Prometheus and Grafana, then what is the purpose of going for ELK stack? What is this ELK? What is the advantage of going for this ELK? Prometheus Grafana use it to monitor your Kubernetes cluster, whereas ELK stack is used to monitor logs of the application. If any problem occurred in the application execution, we are going to check the log files. So to monitor application logs, we are going to use this ELK stack. ELK is the combination of 3 open source products. E stands for Elasticsearch, L stands for Logstash, K stands for Kibana. This ELK stack provides centralized logging in order to identify problems with servers or applications. When we are executing our application on the cluster, there is a chance of getting some exception in that application. For example, when a customer trying to purchase a product, he has doing the payment got failed, but amount deducted from the account of the customer bank. Okay, so customer is trying to do a payment in our website, amount deducted from his account, but transaction failed, product is not booked for that customer. Or customer is trying to create an account in the website, the account is not getting created because of some code issue. There is a problem, project is not executing, there is an issue in the code. Okay, when we get such kind of issues in the project, we will be using log files to monitor the application execution. So for every project, logging will be available. As a DevOps engineer, you no need to bother about what is logging and all. That will be taken care by developers. Whenever a developer writes some code, it is going to, application will have a logging implementation. Application will generate a log file. So it will be something like this, right? Project development is completed. The project is executing. This is our application. Okay, for example, this is SBI application. This SBI application will generate logs into SBI app log file. There will be one log file for our application. What will be there in the log file? This log file contains application execution details. When the request came, today how many requests came, what kind of functionality got executed, everything. Application execution details will be stored into log file. As a DevOps engineer, are we responsible to create the log files? Or log files will be generated by the application itself? Developers will write the code to generate the log messages of the application. When the project is getting executed, logs will be generated. When the project is getting executed, logs will be generated. Let me show you. I'm going to execute one project in my local, one Java project I will execute in my local, guys. So you don't understand what is that code? Forget about what is that code. Just see, one project we are going to execute. When we execute that project will generate some logs. So every application will have some logs. Every application will have some logs. Okay. Let me go to one of the Spring Boot application. Okay. So here there is a Java program. I'm going to run this Java program. Run Java program. It is a Spring Boot application. You observe the console when the program is executing. The program is going to generate some messages about how the program got executed. Those are called logs of the application. Using the logs, developers will understand how the code got executed. See, some messages got generated. Some messages got generated. Application is starting. Application is starting. It took 2.5 seconds to start the application. JVM is running for this. So some logo is printed. So like this, for every application, log messages will be available. When some problem occurred, for example, if I do something like this, in my code, I'm doing some mistake wantedly. I'm doing some mistake wantedly in my code. Let us see what is going to happen. Yes, I got exception. My code is giving some exception. What is that exception? So you don't understand because you are DevOps person. You don't know what is that coding. You don't know what is that exception. But every Java developer will understand what is this exception. Arithmetic exception. When you divide any number with 0, you will get a arithmetic exception in the program. Now you see in my program, I'm dividing a number 10 by 0. I'm writing a line of code in my program 10 by 0. When you divide any number with 0 in the programs, you will get arithmetic exception. So when some kind of exceptions, some kind of exceptions will be occurring in the project. So when the project is executing, we will get exception. How we will understand the exceptions? Developers need to understand the exceptions. DevOps people need to understand the exceptions. Developers should understand the exceptions, or DevOps people should understand the exceptions. Developers should understand the exceptions. Where is our application running? Where is our application running? Applications running on in the real time. Projects will be running on the developer computers. Projects will be running on the Kubernetes cluster. Projects are running on the Kubernetes cluster. Then how developer will see the log file? Application is running on the cluster. Your Spring Boot application is running on the cluster. This is our Kubernetes cluster. So application is executing on the cluster. When the application is executing, application generating some log messages. Application will write the log messages to log file. Where is that log file? Log file is in the Kubernetes cluster. My log file is in the Kubernetes cluster. Then how developer can see this log file? Can we give Kubernetes cluster credentials to the developers to see the log files on the cluster? Can we give these cluster details to the developers so that they can go to the cluster server, they can check the log file and they can identify the problem? Are we going to do that? Are we going to provide that? No. Can we give the access for the developers to operate the Kubernetes cluster? We should not. Application is running on the cluster. When the application is executing, when the people are accessing our application, code will be executed in the application. That code is going to generate some log messages about how the application is executing. Application, whenever user access application, that user request is successful or failure, the logs will be generated by the application. Those logs will be stored to one log file. Those logs will be stored to one log file. That log file is available on the cluster. Developers are available in Hyderabad. My servers are available in the AWS cloud. That's where we are going to use ELK stack. In the Kubernetes cluster, we are going to install ELK or EFK. ELK or EFK, we are going to install on the cluster. These log files will connect to the ELK stack. Developer will connect to the ELK from outside. Developers will be available outside of the cluster. Developers will access our ELK stack to access logs of the application. Grafana Prometheus purpose is different. ELK purpose is different. Grafana Prometheus purpose is different. Grafana Prometheus purpose is different. What is the purpose of Grafana and Prometheus? Grafana and Prometheus are used to access cluster information, not the logs of the application. Grafana and Prometheus are used to monitor cluster metrics. How many nodes are there in the cluster? How much traffic is coming to the cluster? How much network is consuming by our cluster? How many pods are running? How API server is running? How etcd is available? How kubelet is available? How kube proxy is available? How scheduler is working? That cluster data, to monitor that cluster data, we are going to use Prometheus and Grafana. But what about this ELK stack? ELK stack is used to monitor logs of the application. Who will monitor these logs of the application? Developers will monitor the logs of the application. Developer, whenever some issue occurred in the project, developer should understand why that issue, where is the issue, when that issue occurred. For that, developers need to check the log files. Where the log files are available, wherever application is running in that server, the log file is created. Your application is running on the Kubernetes cluster, so the log file is generated in the Kubernetes cluster. Developer cannot access the Kubernetes production cluster directly to see the log file. That's why application log files will connect to ELK stack. ELK stack or EFK stack. ELK or EFK. Elasticsearch, Logstash, Kibana. Elasticsearch, Logstash, and Kibana. We are going to use ELK stack or EFK stack. Okay, application logs will be connected to ELK. How we have the UI for the Grafana, Elasticsearch, Logstash, Kibana. Kibana is one web application which is used to monitor the log files which are generated by the application. You are going to install, as a DevOps engineer, you are going to install ELK stack on the Kubernetes cluster. Then developers will connect to this Kibana server from outside, and developers will monitor the log file. In some companies, people will go for ELK stack to monitor the log files. Okay, guys. So here, in some companies, people will go for ELK stack to monitor log files. In some companies, people will go for Splunk. In some companies, in most of the companies, they will go for Splunk, which is used to monitor logs of the application. Splunk is again a commercial software. Your application log file will be connected to Splunk software, and then developer can connect to the Splunk software, and developer can monitor the logs of the application by using Splunk. But the thing is, Splunk is a commercial software. ELK is open source. Okay, he is a developer. He is a developer. What is the duty of the developers? Developers are going to write the code and will commit the code to GitHub. Once the code is committed to the GitHub, as a DevOps engineer, you are going to deploy that code into the cluster. When the application is executing on the cluster, there is a chance of getting some issue in the application. Some code may fail. I have shown you one example. In my code, I have done some mistake. When this program is executed, I'm getting some exception. How developer will understand where is the exception? Application will have logging. Application will have logging. Application will generate a log file. Application will store the logs into a log file. The log file is generated in the cluster. Developers cannot access the cluster directly. So that's why, as a DevOps engineer, what we do, we are going to install ELK stack in the cluster. We will connect the application log file to ELK stack. We will connect application log file to ELK stack. ELK nothing but it is a combination of 3 open source tools: Elasticsearch, Logstash, Kibana. What is a Kibana? Kibana is a visualization tool. You can search application logs by using Kibana. How we have Grafana, we have a Kibana. Grafana is a monitoring tool for the cluster. Kibana is a monitoring tool for the logs. You understand? What is Elasticsearch? Elasticsearch is used to store the logs. Logstash for shipping and processing the logs. Kibana is a visualization software. So whatever the application logs are generated to a log file that will be connected to ELK. Elasticsearch will store the logs. Logstash will process the logs, will index the logs. Kibana is a web application which will provide the UI to query the logs. Some companies will go for ELK stack. ELK stack is open source. Some companies will go for Splunk. Splunk is a commercial log monitoring software. So when the project is having a Splunk, will you teach us Grafana? Already I explained Grafana, man. Already I told you how to create Grafana. Again is asking, will you teach Grafana? Siddha. Right? Fine. Here we are going to see ELK stack. ELK stack is going to get the log files of the application and it is going to give you application logs. So DevOps engineers are going to see the logs of the application. Developers are going to see the logs of the application. Who will see the application logs? Who is going to see the application logs? DevOps engineers or developers? Developer. Can developer access this directly? Can developer access this directly? No. So we need to provide a platform where developers can access logs of the application. Application is running on the cluster. Application is running on the cluster. Okay, guys. So we need to provide a platform. We need to provide a platform for the developers to access the logs of our application. Are you guys clear? First of all, let me show you Splunk. Splunk is a commercial software, guys. We need to have the license for the Splunk. When the project is having a Splunk requirement, so separate Splunk team will be available for our application. The Splunk administrator will connect our application log file to Splunk software. Now, I can't access the Splunk here, but in my previous company, when I am working in the Deloitte company, I recorded one video when I am monitoring the logs of my application as a developer. So you know that basically I'm a Java full stack developer. So when I am doing that development, when I get some issue, I need to monitor the logs of the application. In my project, we have Splunk software. So for that Splunk, there is a separated team which is going to connect my application log messages to Splunk. There is a separate team. Splunk team is available. So my application is executing. My application is generating a log message to the log file. The log file is connected to Splunk. Log file is connected to the Splunk. As a developer, I connected to the Splunk and I monitored my application log file from the Splunk. Let me show you how I have done that. Not this one, man. Real-time log analysis. Okay. So here I have shown how to monitor the log by using Splunk. Okay. Yeah. So here I'm going to open, see here. So these are my details. They have created a account for me in the Splunk. My company, this video I recorded in the 2018, 4 years back. When I was working in the Deloitte company, I have recorded this video in my office laptop. Right, see here. This is the Splunk URL, RI Bridges Splunk URL I have taken. So that is my project Splunk URL. This is the DNS they configured, DNS. So that is a government project we developed for a US state. Splunk.ribridges.ri.gov. This is my project Splunk software. This is my username and password. Splunk team is available. The Splunk team connected my application log files to the Splunk, right? So they have created an account for me. This is my username and my password. I connected to Splunk. See here, this is a commercial log analyzer. Application logs are connected to Splunk. Now, as a developer, I logged in into my application Splunk software. There is a UI for this. So it is running on my project cloud platform. They configured a domain for that. DNS they have done. Now go inside this. So this is my username. I logged in into this account. Search and reporting. I can search the logs of my application by using Splunk like this. This is a Splunk search query I used. This is the log file that I want to search. I want to search for some data. So this is search query like this. This is a commercial log searching. So a commercial log searching software. Similarly, we have a Kibana, which is open source log monitoring software. Kibana is open source log monitoring software. Okay, Kibana will provide a UI like this. Kibana will provide a UI like this to monitor the logs. Yeah, now see here, I'm writing some query to monitor my application log. And I'm going to click on search. Last 30-minute logs I want to get. I want to search for some exceptions in the log file that I am doing by using this Splunk software. Last 15 minutes logs, last 30 days logs. Like this, you have some options to filter logs of your application. Click on search. Click on search. It is not able to find any data for my search query. Then I will change that search query. That is the log file name. That is the text I want to search in the log file. Yes, now when I click on search, you see, I'm able to see the logs. So when I searched this, when I have prepared this video 4 years back, for my project Splunk is available. My application logs are mounted to Splunk, mounting done by Splunk administrator. They have given the Splunk URL of our project. So whenever there is a problem in the production, we need to check the log details. When the exception occurred, in which program the exception occurred. As a developer, we are going to analyze these logs. We will find out where is the problem in the code and we will fix that problem. Okay, now you understand why we are going for both Prometheus Grafana as well as Logstash, this ELK stack. Guys, you understand why we are using Prometheus Grafana and this ELK stack? What is the purpose? Both are for same. Both are for same purpose or both are for different purposes? Prometheus Grafana is used to monitor the cluster. ELK stack is used to monitor application logs. Used to monitor application logs. Clear, guys? Okay, ELK. ELK stack is a collection of 3 open source products: Elasticsearch, Logstash, and Kibana. ELK stack provides centralized logging in order to identify problems with servers or applications. When your project is executing in the production, there is a chance of getting some issues. So for every project in the real time, logging will be implemented, log files will be generated by the code. So the log files are generated on our servers. Developers cannot access our servers directly. As the DevOps engineer, we are going to control the servers. Developers cannot connect to our server directly. So that's why For developers, we are going to provide a platform to access server logs. Okay, guys. As a DevOps engineer, we will have the control for the servers. You can connect to the servers by using PuTTY or by using MobaXterm. But developers cannot connect to the servers using PuTTY or using MobaXterm directly. So servers are there on the cloud platform. Application is running on the cloud using Kubernetes cluster. Application generating the log files, log messages are available. Developers need to access the log messages of the application to understand the problems of the application. Why the code is not executing, why we are getting exception in the project, why the problem occurred in the project. Developer should understand that. Okay, so to provide log access for the developer, some projects will use Splunk, some projects will use ELK. ELK is combination of three open source products. E stands for Elasticsearch, L stands for Logstash, K stands for Kibana. Elasticsearch is used to store the logs. Logstash is used to process the logs. Kibana is a user interface which is used to search for the log messages. If your project is using open source, then you can go for this ELK stack. If your project having a budget, then you can purchase a commercial software called Splunk software. Here I can't show you how to work with the Splunk, guys. So even I also don't know how to mount the logs to the Splunk. Okay, guys. Splunk administrator will do that process. So I'm not good with Splunk administration. I don't know how to mount the logs from our project to Splunk. In my company, Splunk administrator is available. He will take care of this activity. He will mount application logs to Splunk. Developer will have an account in the Splunk. Now, when I am working in the Deloitte company 4 years back, I was just a Java developer. Okay, there I will write the code. I will push my code to GitHub. That's it. My duty is up to commit the code to GitHub. So there is separate DevOps team who use it to deploy my application on the clusters. Whenever some problem occurred in that application, we will get a bug. Whenever there is a bug in the project, I will go to the Splunk. I will monitor the log file. I will understand where is the problem. I will fix the problem. But in my current company, I'm not just a developer. We are a full stack development plus deployments also we are doing. Got it. Now you understand what is a Splunk and why we are going to use a Splunk in the projects. There are jobs only on the Splunk tool, guys. Splunk is one commercial software. There are jobs only on the Splunk. Prince Reddy, as a developer, you need to monitor the logs in the Splunk or in the ELK. As a developer, you need to monitor the logs on the Splunk as well as in the ELK. So based on the time period, you can monitor. Based on the text pattern, you can search the logs and you need to understand where is the issue. Guys, you got the clarity? What is log monitoring? Why log monitoring is required for a project? What is log monitoring and why we need to go for log monitoring? You got the idea? You got the idea what is log monitoring? What is the cluster monitoring and what is log monitoring? Clear, guys? Okay, good. Now here we need to set up ELK stack on the Kubernetes cluster to monitor logs of our application. Fine. Before going to do this, let us see ELK architecture. Our application will have multiple microservices, microservice 1, microservice 2, microservice 3, like this multiple microservices will be available. Every microservice is going to generate a log. So several APIs will be available. Those APIs are going to generate the logs. All the logs we will be connecting to Logstash. Logstash is going to take the logs, it is going to process the logs, and it is going to index the logs to Elasticsearch. Logstash will connect the logs, transform to JSON message and fed into Elastic cluster. We are going to install Elasticsearch. Whatever the logs generated by our application, those logs we are going to take by using Logstash, and we are going to store them into Elasticsearch. Elasticsearch will be connected to Kibana. Kibana will provide user interface to query the logs. How I queried the logs using Splunk here. You see how I am querying the logs using Splunk. In the same way, you can query the logs by using Kibana. Kibana is a UI, a web application, which is going to provide a user interface to query the logs of your application. We need to set up this ELK stack on our cluster. Got my point? What is Logstash? What is Elasticsearch? And what is Kibana? ELK. Logstash. You see here, Logstash will process the logs and will ship the logs to Elasticsearch. Elasticsearch is going to store your logs. Kibana will provide you a user interface to query the logs. So whenever you search the logs using Kibana, Kibana will talk to Elasticsearch and will give you the log details. Okay, mostly developers are going to query the logs by using Kibana. As a DevOps engineer, you are responsible to set up this ELK stack on the cluster so that the developer can access this Kibana application which is running on the cluster and they can monitor logs. ELK stack. Are you guys clear? Now, we can install these three: Elasticsearch, Kibana, Logstash by using Helm charts. By using Helm charts. Okay, guys. ELK stack is a collection of three open source products. What are those three? Elasticsearch, Logstash, and Kibana. ELK stack provides centralized logging in order to identify problems with servers and applications. Our applications are going to run on the Kubernetes cluster, so we may get some issues while applications are executing. Applications will generate the logs, will store the logs into log file. To monitor the logs of our applications, we are going to use ELK stack, or in some projects we are going to use, in some projects we will be using Splunk. Okay, E stands for Elasticsearch. It is used to store the logs. L stands for Logstash. It is used to process the logs. K stands for Kibana. It is a visualization. It is an visualization tool. Okay, file beats will be available. I told ELK and EFK. Elasticsearch, file beats, and Kibana. Instead of Logstash, you can use file beats, you can use metric beat, you can use packet beat, you can use heartbeat. You can install metric beat, file beats also to collect the data from the log files. Instead of Logstash, you can go for file beat also. Instead of Logstash, you can go for file beat also, which will collect the data from log files. If you want to get the metrics of your cluster metrics, server metrics, application metrics, you can install metric beat. If you want to get the network data, packet beat. Uptime monitoring, heartbeats. Like this. You can install ELK or you can install EFK, Elasticsearch, FileBeat, and Kibana. What is this FileBeat? FileBeat collects the data from the log files and sends it to Logstash or Elasticsearch. Logstash enhances the data and sends to Elasticsearch. Applications are generating the log files. Applications are generating the logs in a log file. Those log files will connect to the Logstash. Logstash will process the log data, will send to Elasticsearch. Elasticsearch is used to store the data. Kibana is used to query the data. Kibana is a web application which is used to query the data. Which is used to query the data. Okay. Kibana displays the data stored in the Elasticsearch. Now you understand the architecture of this ELK. Applications are generating the logs into log file. Those log files will connect to Logstash. From the Logstash, we will send the data to Elasticsearch. Elasticsearch will maintain the data. Kibana will be connected to Elasticsearch, will retrieve the data. Kibana is just a web application which is used to retrieve the data which is available in the Elasticsearch. Who is storing the data in the Elasticsearch? Logstash. From where the Logstash collecting the data? From the application log file. Okay, guys, you understand the difference between Prometheus, Grafana, and ELK. Either ELK or EFK, anything is fine. ELK means Elasticsearch, Logstash, Kibana. EFK means Elasticsearch, FileBeat, and Kibana. FileBeat is also used to collect the data from the logs. Okay, good. Now we need to set up this ELK stack. We need to set up this ELK stack using Helm on our cluster. Okay, guys. So there are set of commands available. We need to execute these commands in order to set up ELK on our cluster. We need EKS cluster. Already my EKS cluster running in AWS cloud. I'm using EKS cluster. Using this EKS cluster only, I created Prometheus and Grafana. I created Prometheus Grafana on the EKS cluster by using Helm. Similarly, by using this EKS cluster, I'm going to set up ELK stack also. Prerequisites: EKS cluster. Your nodes should be having minimum 4 GB RAM. Client machine with the kubectl and Helm configured. We have them. Now I'm going to create one namespace with a name called EFK. Okay, first let me see kubectl get ns. What are the namespaces available? We have default namespace, kube node release namespace, kube public, kube system. These are default namespaces available in my Kubernetes cluster. I want to set up this EFK stack using custom namespace. When I delete the namespace, all the resources also will be deleted. kubectl create namespace EFK. I'm creating EFK namespace. Okay, now let's get it. kubectl get namespace. Now EFK namespace got created. EFK, that means Elasticsearch, FileBeat, and Kibana. Okay, all these ELK stack softwares I will set up by using this EFK namespace on my cluster. I will use the Helm to install these applications. Helm ls. Okay, stable release available currently. It is having only Kube Prometheus stack and the Helm. Now I want ELK stack also. So first we need to add this ELK stack repository to the Helm repository. By using this command, I can add it. Helm repo add elastic. I'm adding the repository with a name called elastic. This is the repository URL. Add it. Elastic has been added to your repositories. Elastic has been added to repositories. Once it is added, you can check it. Helm repo ls. What are the repositories are added now? Helm repo ls, Grafana, Elastic, Prometheus community, metric server, Bitnami, stable. Okay, so my Elastic repository is added. Okay, fine. Once it is added, I am not going to install this Elasticsearch directly, guys, because I want to do some customization. Okay, first I am going to download the values of Elasticsearch. By using this command, you can install Elasticsearch directly. What is Elasticsearch here? What is the purpose of Elasticsearch? Elasticsearch is used to store the logs, right? It is used to store the logs. When we install Elasticsearch directly using Helm, it is going to create 3 replicas by default. I don't want those many replicas now because my memory cluster memory is not sufficient. I want to customize that Elasticsearch software or Elasticsearch application. So for that, I'm going to download the values of Elasticsearch into this file. I will edit those file. I will edit that file. Then using this values file, I will install the Elasticsearch. Without this values file also you can install, but more memory it requires, more configuration required for your nodes. Okay, so that's why I'm going to download the values of Elasticsearch. I'm going to download the values of Elasticsearch. Yes, I have downloaded the values file. Let's edit it. Vi elasticsearch.values file. Now can you see replicas? How many replicas available by default? 3 replicas available by default. I will change to 1 replica. Minimum master nodes. It is expecting 2 master nodes minimum. I'm making it as 1. Guys, see here. I'm taking the Helm values of this Elasticsearch. I changed that file. Replicas as 1, master nodes as 1. So I changed here. Replica as 1, master node as 1. Then save this file. I saved it. Once it is done, I'm going to install Elasticsearch using the file which I have modified, and I'm going to install this using namespace, custom namespace. We already created a namespace. I want to install this Elasticsearch in this namespace only. I'm going to specify -n namespace name. If I don't specify, it will install into default namespace. Okay, let's install it. Helm install Elasticsearch with this file -f file name -n namespace. Elasticsearch got installed by using Helm. By using Helm, Elasticsearch got installed. Now let us check our namespace. Is it really installed? EFK namespace. Can you see Elasticsearch available? It deployed. Elasticsearch deployed to my cluster. Kubernetes cluster is available. In that Kubernetes cluster, I have created a namespace. Namespace means cluster inside the cluster. Within this namespace, I am installing ELK stack. This namespace is available in the Kubernetes cluster. In this namespace, I am installing ELK stack. It is a cluster inside the cluster. Once it is done, get all the details available in this namespace. Yep. ELK namespace, you see. Elasticsearch is running as a pod status. Elasticsearch running as a cluster IP service. It can be accessible within the cluster. It is running as a stateful set. Elasticsearch running as a stateful set. Right. Once this Elasticsearch is installed, I'm going to install Kibana. To install the Kibana also, I'm going to do some customization. For that, I'm going to download Kibana values file first. Okay. Helm show values elastic Kibana Kibana.values. I'm going to get the Kibana file. Kibana values I got. I will customize the Kibana using this values file vi Kibana.values. I will edit this file. Go inside this. What we need to edit in the Kibana? The very first thing is Kibana service type is available as cluster IP. I will change it to load balancer. Service type. What is the service type available for Kibana? Cluster IP. But what is the meaning of Kibana? What is the purpose of Kibana? Kibana is used for log monitoring. Na? Everybody in the project should be able to access the Kibana. Everybody should be able to access the Kibana. Kibana should be accessible outside the cluster also. But Kibana is deploying as a service as a cluster IP. Cluster IP means within the cluster only we can access. I want to provide the Kibana access for all the developers outside the cluster also. For that, I'm going to change this service from cluster IP to load balancer. Load balancer. What is the port number it is taking? 5601 is the default port for the Kibana. I'm changing the port number to 80. You can change it. Not only load balancer, guys, you can make it as a node port also, no problem. You can make it as a node port also, no problem. I'm making it as a load balancer. Anything is fine. Cluster IP means within the cluster. Node port means outside the cluster also with node IP. Load balancer means one DNS will be generated. So that is what I told here. Kibana set replica as 1. Change the service type from cluster IP to load balancer. Change the port number to 80. So I'm just making the changes to values file. Replicas, see how many replicas available for Kibana by default. One replica only available for Kibana by default. I'm making just 2 changes in the Kibana values file. Cluster IP, I change it to load balancer. Service type, I changed it from cluster IP to load balancer. Port number default 5601 available. I changed that port number to 80. Okay. Then save it. Yep. Kibana values file got saved. Once the Kibana values files got changed, now you can install Kibana. In order to install the Kibana, I will use this namespace which I have created. I will use the values file which I have created. Okay. How to install this Kibana? Helm install Kibana. Name I am giving for this. This is the repository and this is the values file. In this namespace, I want to install. Helm install Kibana. Helm install Kibana. Elastic Kibana values file in this namespace. I'm installing. Yes, Kibana got installed. So we installed Elasticsearch and we installed Kibana. What is the purpose of Elasticsearch? Elasticsearch is used to store the logs. What is the purpose of Kibana? Kibana is used to monitor the logs. Kibana is used to retrieve the logs from the Elasticsearch. But who will give the logs to Elasticsearch? Either you need to go for Logstash or you can go for FileBeat. I will go for FileBeat. Before going to do the FileBeat, let's install Cube. Let's check it. What all the things installed in our namespace now? kubectl get all -n EFK namespace. Oh, so many things are there. Now you see, Kibana is installed and running as a load balancer. A DNS got generated for the Kibana. Using this load balancer DNS, we can access Kibana UI outside the cluster. Are you guys clear with my point? Are you guys clear with my point? Are you guys clear with my point? Okay. Now, once this Kibana got installed, now we are going to install the Logstash or FileBeat, which are used to collect the logs from the log file and store into Elasticsearch. Okay. So for FileBeat, you no need to do any customization. Directly you can install FileBeat. Helm install FileBeat under this custom namespace. Helm install FileBeat under this namespace. I'm installing it. Yes, FileBeat got installed. Check the service. All. Okay. Guys, FileBeat installed as a daemon set. What is the meaning of daemon set? Logs it should collect from a particular node, or it should collect the logs from all the nodes. I explained a daemon set, right? What is the meaning of daemon set? What is the meaning of daemon set? A copy of the pod should be executed in all the worker nodes. My application will be running in multiple nodes, right? From every node, I need to collect the log files. So my file beat should execute in every node. So which pod will execute in every node? Daemon set pod will execute in every node. So they have given file beat as a daemon set by default. When I'm explaining daemon set, people asked me, when you will execute a pod in all the nodes? File beat, which is used to collect logs from all the nodes. The file beat will collect the logs from all the nodes, will give to Logstash. Logstash will send the logs to Elasticsearch. From Elasticsearch, Kibana will retrieve the logs. Kibana will display the logs for you as a web application. This is ELK stack setup. Now I have configured Kibana. I configured Elasticsearch. I configured FileBeat. If you want metric beat also, you can install metric beat also. If you want, you can install the metric beat also under this namespace. Okay. What is this FileBeat and metric beat? FileBeat is used to collect the logs. Metric beat will collect the metrics of your servers. You can install metric beat also in the cluster. Use a Helm in the same namespace. My metric beat also installed. So what kind of service this metric beat is? See here, -n EFK. Now metric beat is installed as a replica set. Kibana is installed as a deployment. Elasticsearch installed as a stateful set. FileBeat installed as a daemon set. FileBeat installed as a daemon set. Why? This FileBeat should install in all the nodes. The pod FileBeat is running as a pod. This FileBeat pod will be running in all the nodes because nodes should be collected from all the nodes. Kibana is a web application. It executed as a deployment. Kibana I executed as a load balancer type because I want to access this Kibana outside the cluster. The default type of the Kibana is a cluster IP. I change it from cluster IP to the load balancer to access it outside the cluster. FileBeat is executing as a pod with the help of daemon set. Kibana is executing as a pod as a deployment. Right. Metric beat is executing as a replica set. Elasticsearch executing as a stateful set because the logs which are generated once the pod or once the service is deleted, logs should not be deleted. So it has to maintain the logs. Even if the pod is deleted, my logs should not be deleted. That's why it is using stateful set. All the sets are available. Replication controller, deployment, daemon set, stateful set. Got it. Yeah, stateful set I have not explained it, guys. I have to explain the stateful set. I will explain the stateful set also. I will cover it. Stateful set and volumes I have not explained. I will explain that. Got it? How to set up ELK stack on the cluster? You got the clarity? What is Prometheus? What is Grafana? What is this Elasticsearch, Kibana, Logstash? Okay, guys. Now, in tomorrow's session, I will show you how the logs can be monitored by using this Kibana. I need to prepare one application which will generate the log file. Before coming to tomorrow's session, I will prepare one Spring Boot application with the logs. When we access that application, logs will be generated. I will make that application and I will create a Docker image for that application. Tomorrow, we will deploy that Spring Boot application on. Tomorrow, we will deploy that Spring Boot application on Kubernetes cluster, which will generate the logs. Then I will show you how to monitor those logs by using Kibana. Okay, application is not ready now. I will make that application and I will show you that. Are you guys clear with this? I used ELK stack. I'm setting up on my EKS cluster, guys. You can do that on the normal cluster also, no problem. I used EKS cluster. My EKS cluster is running in the AWS cloud. I connected to EKS cluster by using remote machine, and I used Helm to install all these monitoring tools. Prometheus I installed by using Helm. Prometheus Grafana together we installed as a Helm chart, and the ELK stack also I installed by using Helm charts only on my EKS cluster. So before coming to tomorrow's session, I will keep one application ready, Spring Boot application, which will have the logs also. When we access that application from the cluster, logs will be generated. How to monitor those logs by using Kibana, that work I will show you in the tomorrow session. Tomorrow session. Clear, guys? Fine. Now, coming to Kubernetes, the things that are pending from my end, one is volumes, another one is a stateful set, config map with secret, config map and secret, and RBAC. Okay, these 4 topics are pending from my end: volumes in the Kubernetes, stateful set, config map with secrets, RBAC. All these 3 I will cover in one example. RBAC is role-based access for our pods. We will discuss about it also. Okay, these 4 things are pending from my side. I will cover those also, guys. And next one, tomorrow I will show you practically how the logs monitoring will happen in the real time by the developers, right? How the developers will be using this Kibana and all. We are going to discuss about it. Yeah. Repository. Repository I need to explain, guys. An Nexus server I'm going to explain. Nexus server I'm going to explain for you. Okay. Nexus server I will explain how to store our build artifacts to the Nexus. Okay, mostly this by this weekend I will try to complete. Tomorrow and day after tomorrow. Whatever the topics are pending for us, I will complete those topics by this weekend.